Thanks for checking in. We're going to talk about the balancing act on day 3. We talked about nitrogen cycle in our first video for day 3. The second video right now that we're working on right now is going to talk more about experimental design. So we are going to start learning more things about experimental design in this class, and then on day 4 we will do some more with experimental design. So if you look at the beginning of your notes, we've already read some of this information, but you can see that it says in this investigation, you will conduct an experiment to determine the effect of nitrogen on aquatic plant growth and water quality in aquatic ecosystems. This is true. We are going to do some more experiments and we are going to do some more water testing. So that'll come up in the next couple of classes. But in order to do that, we need to understand how to come up with the experiment that we want to do so that it's going to give us data that we can use. So we need to know the basics of how to set up any experiment properly. All right, you have probably seen an experimental design diagram sometime in your elementary school career. You would have had some sort of a title like the effect of something on the something else. That's the title. It's telling you what the experiment was trying to learn about. In any sort of a test situation like this, we have a hypothesis. We are trying to make some guesses about what's going to happen. And we're trying to be logical and make an educated guess. So the educated guess is going to be the hypothesis. The hypothesis usually is an if this happens, then that will happen type of statement. So I'm certain that you have at least talked about title and hypothesis. You have probably talked about some of these other words that are on this experimental design diagram as well. So I'm going to ask you to do a sort in the classroom and try to figure out which vocabulary goes with which definition. So one more time, the experimental design diagram, that EDD, it's a game plan or it's a blueprint. It's a plan so that we can test something that we're thinking about or wondering about. So we have this example about Mr. Lee. Mr. Lee's cat, Hallie, is not sleeping very much. Mr. Lee wants to see if changing his cat's cat bed would affect the amount of sleep she gets. So he's going to do some sort of an experiment to see. All right? In order to make sure that his results of the experiment are valid, he's got to make sure that he's planned ahead to do his experiment. So you are going to go through and each class, each table in the classroom got a baggie with 9 different terms. And students worked in pairs to lay out the terms right next to their appropriate definitions. All right, so you are matching if you are in the classroom. If not, you are probably just going to be filling in paper notes to make sure that you have the right word by the right definition. Some classes did this in the other direction on your notes. Some classes just had to write the key term. Other classes actually had to write out the entire definition. So depends on which class you were in. All right, we gave everybody about 3 minutes to work on that, and then we checked over the work. So our first definition is it's a prediction that can be tested, and it's written as an if-then statement. So it's a best guess. If this happens, then that will happen, right? That's going to be our hypothesis. The next thing we looked at was it says it's a factor changed by the experimenter in the experiment. So it's something that is going to change or vary, V-A-R-Y. So if it's something that's going to vary, it means it's a variable. Now you have to figure out whether this is the independent variable or the dependent variable. And the way a lot of people remember this is if I'm doing an experiment and I make a decision to change something, I can stand for me and I can stand for independent. The factor that's changed by the experimenter is the independent variable. So Mr. Lee is going to change the type of cat bed. That's his independent variable. Okay? Now, the factor that responds to the change that we made, that's the dependent variable. So Mr. Lee is going to change the type of cat bed. How will he know what that did? Well, he's going to measure how long the cat sleeps, right? So whatever it is that you are going to measure is your dependent variable. All right. We have a summary of the whole plan for the experiment. This could be blueprints, right? This could be a game plan. So our summary of the whole experiment, we call it an experimental design diagram. It's really like a graphic organizer. All right. Next, we are thinking about factors that remain exactly the same in every single experiment. So for Mr. Lee, he's going to use the same cat each time, right? So that's going to be a constant. Mr. Lee also might always use the same bedroom or something that he's leaving the cat in. So things that are not going to change, those are constants. All right, so back to thinking about our independent variable. Mr. Lee wants to know if different kinds of cat beds are going to allow his cat to sleep better. So he might choose to let the cat sleep in a fur-lined cat bed one night. Maybe he'll try a crinkly tissue paper bed one night. Maybe he'll try a flannel bed one night. But every single one of those changes that he's making, those are the levels of his independent variable. The levels of the independent variable. It's going to be the different changes that are made to that independent variable. All right. So if we're thinking about the standard of comparison in an experiment, it means we want to know what would happen if we didn't actually change anything, if we just measured the amount of sleep that the cat is getting without changing anything. Okay, absolutely no changes. That's going to be your control. When you are controlling everything so that you have a baseline, you're figuring out what's going on. Okay. Next thing, the number of times the experiment is repeated. How many tries did you give it? How many times did you try it? That's going to be the trials. And finally, we'll have some sort of a statement describing the whole experiment to let somebody know what somebody was trying to find out. So it will be the effect of something on something. Mr. Lee is going to have the effect of type of cat bed on the number of hours my cat sleeps, right? Because his independent variable was the type of cat bed, and his dependent variable that he's going to measure is the amount of time the cat sleeps. This is our title. That's the title of our experiment. It gives a lot of information. All right. And so after everybody lined up all of those definitions and their key terms, I asked people to either fill in the definitions if that was what they needed to fill out on their own paper, or I asked students to use the definitions on their page and fill in those keywords. All right, so you want to make sure to get a copy if you weren't in class. Then I said, please put all of your key term words back in their baggie if you were in the classroom, so that we could return that back to the back of the room or the front of the room. All right, so that was pretty much the end of day 3. Thanks so much for watching, and we will do some more with experimental design when we come back. There was no exit ticket for day 3.